Okay, so let's review for the test this week. Um, so this test is basically covering the stuff from chapter 3, and basically the first half, or maybe even more than the first half, was just how to do the derivative of elementary functions. So we learned how to do the derivatives of powers of x and e to the x and trig functions and logarithmic functions and really all elementary functions. We learned the product rule, the quotient rule, the chain rule, that type of stuff. So on the test, there's definitely going to be probably a few questions that just say find the derivative of this function, or also like another simple variation of this is to find a tangent line. But yeah, the main work of finding a tangent line is finding the derivative because that's the slope of the tangent line. So let's do a couple like this. So find the derivative of this function. So I'm going to give you a sort of complicated function that you have to pick apart. And what my eyes do when I'm looking at this is my eyes, first of all, notice that I see a fraction. I see a big line with a function on the top and a function on the bottom. So that tells me that the big picture here should be the quotient rule. And I can take things slow here. So let me do that. The easy part to remember for the quotient rule is that the bottom becomes squared, and then the top is it's this times the derivative of this minus, and then I'm going to do this the other way around. It's going to be this times the derivative of this, right? Now let me actually do these derivatives. Like I have to fill in this one and I have to fill in this one. So this part isn't hard. This is just addition, so I don't need to use like the product rule or anything in here. I just do the derivative of cosine, which is negative sine, and then the derivative of e to the x is just e to the x. Minus, okay, then I've got this, times, okay, the next thing. Right, so now I'm doing the derivative of this, and I see multiplication in here. This is the square root of x times the natural log of x. So that means I'm going to have to do the product rule. Of course, let's think of, and maybe instead of writing the square root of x, maybe I should have written x to the 1/2. But that's okay. I didn't write it, but we know that that's what it is. This is x to the 1/2, and thinking of it that way helps me to take the derivative. So, okay. Once again, I'm doing the product rule. The product rule requires me to, maybe I'll do the easy part first. I'll leave this one alone and multiply by the derivative of this one, plus, and then I do this the other way around, I'm going to leave the natural log of x alone, and I'll do the derivative of this one. And since this is x to the 1/2, its derivative is 1/2 x to the negative 1/2. And yeah, sorry, I really should have left myself a bit more space here, because I need to do that times ln x, and then I can close those parentheses. And that's all over this. And for this test, you don't have to simplify your final answer. Obviously, this is a complicated thing. I could there are a few obvious things I could simplify, like the square root of x squared. I could cancel some power of x here, but because this is such a mess and I don't want you to spend a ton of time simplifying your answer, you can just put a box around this and say that you're done. As long as you don't have any d over dx in your final answer, you should actually do all the derivatives. So don't leave any d over dx in your final answer. So I couldn't just put a box around this one and say it's my final answer, but this one I can. Okay, let's do another one like that. Do the derivative of this. Notice this one involves an inverse trig function. I put an arc sign in there, so you should know the derivatives of those. Those are in section 3.6. So, okay, let's go. And just to remind you, maybe I'll put this in a little bubble down here. The derivative of arc sine is 1 over 1 minus x squared with a square root there. Okay, so what do we have here? As my eyes go over this and start picking it apart, I notice that there's multiplication. I've got this thing times this thing. So I'm going to start picking this apart, and the first thing I'm going to use is the product rule. Meaning I'll leave this one alone and multiply it by the derivative of that one, plus, and then I will do this the other way around, I will leave this one alone and multiply by the derivative of the other one. Right? Okay, now I have to actually do these derivatives that I wrote down. So let's take a look at this one. This one, I would say, looks like the chain rule, because I see a function inside of another function. The outside function is the natural log function, and the inside function is 2x plus 3. So the derivative of that, because the derivative of ln x would be 1 over x, so I'm going to have 1 over this. But then for the chain rule, I have to multiply by the derivative of the inside, which is just 2, right? Plus, okay, now I've got this. Now I have to do this derivative. And I would say this is also the chain rule. The outside function is the arc sine function, and the inside function is x squared. So I wrote the derivative of arc sine here, but since we're using the chain rule, instead of this x, I'm going to put in x squared. So this is going to look a little bit funny because you might be looking at this and saying it's already x squared, but here's what I mean. I'm putting x squared in for x. Like I put x squared in for this x, meaning that it gets squared and squared again. So it's going to be x to the 4th. And I would multiply that by the derivative of the inside, which is 2x. And yeah, I guess, like I was saying, for the purposes of this test, I don't want you to spend a lot of time doing algebra to simplify your answer. So I'm going to go ahead and put a box around that and just say that it's good. Of course, like I was saying, this x squared, I could simplify that and say that's x to the 4th. But I just don't want to write this whole thing again just to simplify that one part. I don't want that to be how you spend your time on this test. So you don't have to simplify this any more than it is. Once again, I didn't leave any d over dx in my answer. I did all the derivatives, but I'm just not going to simplify it. Okay. Another type of question that might show up on the test, well, will show up on the test actually, is implicit differentiation. So let's take a look at this one. Let's find y prime if we're given this equation. And so the step, the hardest step is kind of the first one. It's where you do the derivative of both sides. The most common mistake that people make is they don't know where to put a y prime and where not to put a y prime. So let's go over that. I'm about to do the derivative of both sides. I'm going to have to use the product rule on this one, and then separately I'm going to have to use the product rule on this one. So here I go. Let's do the product rule on this one. The derivative of x squared is, of course, just 2x. And then I leave the y cubed alone. There's no y primes that go on this. Because the thing that I did the derivative of, because I'm in the middle of the product rule, I'm doing the part where I did the derivative of x squared, and the derivative of x squared is just 2x. It doesn't have any y primes on it, nothing like that. So let me keep doing the product rule. Now I'm going to do the part where I leave the x squared alone and I do the derivative of y cubed. For y cubed, I have to basically treat this like the chain rule, where the inside function is y and the outside function is the cube function. So this derivative, when you do something like the derivative of y cubed, here's one way of thinking of it. If I was doing the derivative of x cubed, it would just be 3x squared, right? But I'm doing the derivative of y cubed, so what it's going to be is 3y squared times the derivative of the inside function. I'm really trying to emphasize why this one has a y prime on it and then the other one didn't. It's because we were doing the product rule, and the first part involved doing the derivative of a function that just involved x, and the second part involved doing the derivative of the part that involves y. That's why that one has a y prime on it. Okay. Let's do this again on this one. Again, I have to use the product rule. First, let's do the derivative of x cubed. That's just 3x squared, and I'll leave the y squared alone. This one does not have a y prime on it, because on this one I was just doing the derivative of x cubed. It's stuff that, the part that I was doing the derivative of is stuff that only involves x. But now I'm going to have to do the other part because this is the product rule. So I'm going to leave the x cubed alone and do the derivative of y squared. If I was doing the derivative of x squared, of course it would be 2x, but I'm doing the derivative of y squared, so it's going to be 2y, y prime, because this is the y prime is like the derivative of the inside. And that equals 0. Of course, another common mistake would be to write that this equals 1, because you're forgetting to take the derivative of the right side. But that's what we're doing. We're doing the derivative of both sides. So if you have a constant, then it becomes 0. All right. The hard part is over. Now we have just some slightly... No, it's not that bad, but just a little bit of algebra. So, as you know, certain parts of this have a y prime and certain other parts do not have a y prime. I'm going to keep all the parts that have a y prime on one side, and then I'm going to move everything else to the other side. And Since I want this to go fast, let me go ahead and pull out y prime. So here's what's happening in this step. I'm going to move this over to the right. I'm going to move this over to the right. This and this are going to stay on the left, and I'm going to pull the y prime out. So inside here, I'm just going to write what would be left after pulling the y prime out. So this is 3x squared y squared, and this is 2x cubed y. And then on the right, I've got a negative this and a negative this. Finally, to solve for y prime, I've just got to divide by this. And that's it. Okay. So let's do another one that involves implicit differentiation. Only this time, instead of finding a formula for y prime, we're finding the tangent line. So we're given this curve, and we're given a point to find the tangent line at. The first step is going to be the same as the first step was before. I'm just going to do the derivative of both sides, looking at this. So, yeah, let's just do this. Here I've got a product rule. So the derivative of 2x is just 2, and then I leave the y alone. And then for my second part of the product rule, I'm going to leave the 2x alone, and I'll do the derivative of y, which is y prime. Now let's do this one. The derivative of 3x is just 3, and then I'll leave the y squared alone. And then for my second part of the product rule, I'll leave the 3x alone, and I'll do the derivative of y squared. The derivative of y squared would be 2y, y prime. So far, this has been similar to the last one. And then I've got this part. Sine of x minus y. So for this, I'm going to do the chain rule. The outside function is sine, and the derivative of sine is cosine. So I'm going to have cosine of x minus y times the derivative of that inside. The derivative of x minus y would be 1 minus y prime, right? And I'm almost running out of space, but that would equal 0 because that's the derivative of 5. Okay, now here's what I could do. I could do what I did last time, which is move everything without a y prime over to the right and factor y prime out and then divide by everything to solve for y prime. I am not going to do that for this one. Here's my recommendation. I'm not saying that would be a bad way to go. You can get the answer that way. It's just harder than what I'm actually going to do. And the reason why I'm not going to do that is because we don't really need to know what y prime is at every point on the curve. We only need to know what y prime is at this point. And if that's the case, it would be smarter for me to just plug in these numbers everywhere here for like 1 goes in for x, 1 goes in for y, 1 goes in for x, and do that everywhere, and that's going to be a lot easier to look at than this messy kind of thing involving cosines and y-squareds and all of this business. So that's what I'm going to do. So this just turns into 2 plus 2y prime plus 3 plus, I guess, 3 times 2, so 6y prime minus, okay, x is 1 and y is 1, so this would be cosine of 0 times 1 minus y prime. Okay, and keep in mind cosine of 0 is 1. So this, and I can sort of simplify, so I've got a 5 plus 8y prime, and this is 1, but let me distribute the negative, so it's going to be a minus 1 plus y prime equals 0. And let me simplify this even more. 4 plus 9y prime equals 0. And I can solve for that, so it would be negative 4/9. That's the slope of the tangent line, and so here's the equation of the tangent line. Y minus 1 equals negative 4/9 x minus 1. I just got the 1 and the 1 from here again, and I got the slope from here. That's the tangent line. Okay, actually, I have more problems to do, but I'm going to make this a separate video.